Right. Right, today in this video I will be doing a delidding of a Intel Haswell CPU, the i7. If you guys aren't aware of what delidding means, basically I will be taking off the steel heat spreader on top of the CPU on the PCB, so the shiny part which is stuck onto the green part, I'm going to be separating them, and I will be reapplying the the thermal grease and sticking everything back together and seeing how much the temperatures will drop by. I have heard people say, and I've read numerous reviews, that Intel haven't done a very good job at sticking the thermal the heat spreader to the CPU core in Haswell. Thus, the core temperature gets quite hot, and people, I've seen other videos and I've read other people, I've read articles on it where some people are achieving a drop in temperature of around 30 degrees Celsius, which is a massive drop. If I can achieve half that, I will be happy. But it's not just about the temperature drop, it's just about the funness, the excitement of the thing. You can possibly brick or destroy a brand new CPU costing almost 300 in the UK. So yep, exciting stuff, and we will be doing this in a few minutes. So I'm just going to continue the video on, and after this sort of the temperature which you can see in the background and everything, so then I'm going to just attempt at filming a delidding. Now I must apologize if my videos, the actual video, is not very good, or if you miss certain parts, because I'm quite new to this and I'm doing all this myself, and I don't have a lot of space really to do it in, so I do apologize in advance for that. Right, so if you see my temperature right now, you can see they're sometimes exceeding 90 degrees, and the CPU is at 4.5 gigahertz. So and they're exceeding 90 degrees on running Ada 64. If you are looking at the temperatures on the Asus AI suite, then is 74 degrees, because so I have real temp and the Asus AI suite, and you can also see this CPU Z on top as well. So I will be back shortly with the actual delid process, so stay tuned, and I'll turn off so I can work more freely. So I think with these things, I believe it's good to have plenty of space as well, especially after the CPU is being delidded. This, oops, Oh. That's not good. Let me see if I can find a better screwdriver anyway. So this fan is now off, and I'm also going to take some of these RAM off as well. Well, in fact, I'll just take them all out. So let's put these. Okay, so now we can get to work taking off the water block. Oh, come on. Just been dropping everything everywhere. I just hope that last drop didn't. You know, the right tools is very important. So found a suitable screwdriver, and we can now proceed to removing the water block. Is the right now to remove the CPU. Let's see which way the CPU fits in. Let's just take a picture so to avoid any mistakes later. And we can get to removing the CPU now. There we go. CPU is removed. I'm gonna take some tissue, and I'm gonna start to wipe this part clean. You need to make sure it's very clean. I actually had on previously the Arctic Silver 5 thermal paste, which I believe had some silver in it. So alright guys, okay, so now we have the CPU out of its socket, and just remember to be very careful with this, because we don't want to damage anything. Let's clean this off. Whatever's left we can clean off in a little while. So let's just put this here for now and get everything else ready. Okay, so to get started, I have some gloves. If you have some, you can try use them, so to just avoid the static or any risk of damaging the CPU. I mean, in this process there are plenty of risks to the CPU, so let's try and minimize one of them. I have some Gillid Extreme CPU paste. Just brought this brand new. I did have one previously, Arctic Silver 5, so this is the Gillid Extreme. You need a blade or something thin. My one is, I just want to try and use this, see how this works out. And also I have this silicone. It's a high temperature resistant silicone, and I may use this to reapply it to the CPU on the case once I've done this. So, and I need some nicotine as well to calm down. Okay, that was my blast of nicotine. And with the Gillid, I should also have an applicator. They also give me an applicator which I misplaced. There we go. This is my applicator for the thing. So basically, from what I have seen, okay, let's get this clean. I think I got the old thermal paste everywhere. I think I applied a bit too much. So, right, so from what I've seen people doing in the past, you really don't want to insert this knife too far into the chip, because it can damage some of the components. So basically, if we just keeping it straight, if we can just you know, I don't really need to do this, and I am doing it for some reason, because maybe I'm just a bit crazy like the rest of the YouTube guys, but wow, this is like stuck on very, very well. So guys, you know, it's my first time I'm doing this, and I must admit, you know, it's quite scary, because although I'm doing this, however, I do not feel extremely confident at, I'm not sure if you can see it, but let me just see if I can show you. just here, there is a little bit of thermal paste, which is somehow got on there from my gloves. So I've changed my gloves over now, and I'm hoping that little bit of thermal paste will just rub off. I think it should be okay. These things are so sensitive, aren't they? Okay, so let's start again now. Forgive me if this is a long video, but you can forward some of the parts if you wish. There we go. I think it's best to start with the corners and I am a little bit disappointed with Intel. Also, be careful. I'm not sure if you can see it, but the PCB can bend, so just try to not apply too much pressure and bend the PCB. You know, if this works, it's worked. But if it breaks, I think I'm going to be quite disappointed if I do damage this. Also, be careful to not to go too deep, as there's all these cool things inside the CPU that's, I'm sure, is quite sensitive to, likely to get damaged. And I am hoping nothing gets damaged. So and if it does, then it does, and you know, oops, I don't want to push it in too far, and fine. There we go. Oh. I think Intel should have soldered it in, or just not glued it in so much. I think I'm almost there now. I'm thinking having a thinner blade would probably have been a bit better. And we have a D-lid here. I truly hope it's not been damaged anyway at all. it's quite hard to imagine that there is it millions, hundreds of millions, or billions of transistors, and other cool things inside here. Billions. And if you just damage a single of this tiny little thing, then you are, for lack of a better word, actually I won't say it, but you are in trouble. So let's put this thing here, and I'm just going to pause for a second. So now if we just put this here and use the knife and take off all the silicone that's in there already. So taking the CPU apart, not too difficult. However, it remains to be seen if we still have a working CPU or not. Still remains to be seen. We may have a working CPU, or we may not have a working CPU. So once we have cleaned all this up, we can plug it in, and if everything works and the desired temps have been achieved, then it's been worthwhile. And if it's not working, then basically it's been a learning experience, and I've just blown a brand new, very expensive CPU. Use the blade. Just slowly take this glue off. Sorry guys, I'm not talking right now because I'm trying to be very careful, and get some of this this glue off. Let's try this part again. You know, it's rather ironic when, I suppose, when Intel make these, they have all these clean factories, clean rooms, and the staff wearing protective suits, clothing, so to not have any dust or dirt in the atmosphere when they are producing these rather marvelous products. And myself and other people on YouTube doing this to them is but again, I suppose if Intel had provided a better thermal solution to this, then we would not have the need to take off the TCAS and do all this. So I think the fun part sometimes is just messing about with things, experimenting. And okay, I'm gonna pause again for a second. I need a break, and we'll continue again. Right, guys. So I cleaned off the heatsink thing as the best as I can, and I'm gonna just open my thermal interface material, see how it is. Okay, and I'm just gonna apply very, very lightly. So very lightly indeed, and I am going to use the applicator which they supply, this applicator, and to just apply it evenly. Now this paste isn't conductive, electronic conductive, so even if it does spill over a little bit, isn't going to be a huge problem. So we're still trying to not get it everywhere. Right, so now is the time to install, so I'll just reposition my camera and I'll... Okay, so time to reinstall the CPU. Now, first of all, be sure to align the CPU with the dots and everything. So how does it go? I think the CPU should fit just like so, just nice and gently in there, and then Then you just put the you put the heatsink back on, just like so, and you put on the just make sure to center it properly, so it's actually on the center, and just close this thing off. I think it's not fully centered, so let's just so now I'm gonna have to reapply some thermal paste to the CPU, well, the outside of CPU, and the CPU is this way, so it's going to apply some paste in this direction, like so, and so we just need to apply this. Applying the Arctic Silver paste was much easier. May need to apply a bit more. This paste seems to dry very quickly, so just seems to set very quickly, and isn't very applicable. So I think how I applied it may not be the best application ever, but I think the CPU is just around here somewhere, so I don't know. This Corsair fan cooler, I think, also needs to fit very nicely. If it's not fitted properly, then we are in trouble again. So this is the most awkward cooler. You can fit the pipes on this thing quite strong, and you just have to tighten it in a sort of like a cross tighten them, so one corner at a time. With this one, tighten this, tighten the other one, and so I'm just gonna tighten everything up and fire up, and if it works we'll do a the temperature test again. If not, I'm gonna most likely be crying for the rest of the night. So fingers crossed, and fingers crossed anyway. Okay guys, so I've done the deleting now, plugged everything back in, and thankfully nothing's damaged, so everything seems to be working fine. I'm just gonna do the stress test again, just like before, and we can compare some of the temperatures. Right, so if you see on here the idle temperature now, the CPU is not at load. I'm not really using anything apart from screen recording, so still everything's at 45x, so 45 times multiplier. And let's just start this up now. And if you see, the temperatures are not too bad actually now. They're not exceeding 80, so even at the maximum point, ignore the Asus AI suite, because if you're stressing the CPU, I've seen sometimes it just freezes and it doesn't always work. If I bring the Intel, as you can see, the voltage for the CPU is quite high again. It's 1.376, which is quite a lot, and the temperatures are generally staying under 80 degrees. If you see the core 1, 2 and 3, 1 and 2 have peaked above 80 for a brief second, and the core 3, and let me just reset these. Okay. So pretty much I could leave it like this now for an hour, and it'll still be like this, you know, the same temperatures. My fan, the CPU fan, isn't even spinning at full speed because I got a silent profile on. So, and the deleting has helped anyway. It has helped, and I've actually like previously, if I went up to 4.6, I would hit the throttle point at 100 degrees easy. Now it's not so bad. I watched a video on YouTube from the Asus marketing guy with Newegg, I think, and they had a overclocking video and everything, and he said that you couldn't apply this much voltage unless you had a really high end cooling solution. And my cooling solution is really only a Corsair H80i, and I can still dissipate 1.376 volts and keep the temperatures reasonably low, even in an under stress test. So if I was playing a game or something like that, I don't think I'd hit 80 degrees, no way. And if you see, every single core has hit 1.376 volts, every single core, and even one core is 1.392. So I'm gonna wrap it up now. Hopefully you guys have enjoyed the video, and